In this question, basically a tube is filled with water, or a tube which is closed on both sides. It is closed on both sides, and a tube is filled with water, and its density is given that its density of water is Pw. Density of water. Density of water. So now it is actually it is performing in rotation motion along a axis from its which is located on its one end. Now from the axis of rotation there are two manometers which are fixed on the tube at distance r1 and r2. 1 minute. So basically r1 at distance r1 and r2, there are two manometers is manometer is attached to the tube, and they are calculating the pressure P1 and P2. P1 and P2. And now we have to determine the angular velocity through which the tube is rotating. Now actually it is given that there is a tube P1, this is, and there it is calculating T2. This is arising at radius R1, and this is radius R2. Now it is moving with angular velocity omega, and we have to calculate angular velocity mu. So in order to calculate the angular velocity omega, it is very easy. Just assume that, or calculate the pressure at distance x. Let the small element of water of length dx, let the length dx of the tube which will be x distance from axis of rotation, from axis of rotation. Now just calculate pressure or force. Now pressure on small section will be, now actually pressure is nothing, it's a force per unit area, and actually it is rotating in around the axis of rotation, therefore force is mr omega square. We can know that, therefore pressure is mr omega square by a. Now for mass we know that density of water will be rho w, and let dV with the volume of this small dx. And radius will be the distance from the axis of rotation, so this will be x and this will be omega square. Now area of this small section will be, let this will be, area will be A. because there is no effect of area. Now dp is equal to dw this will be area A, and dx length will be dx into x omega square by A. Therefore A get cancelled. Therefore dp is equal to pw omega square x dx. Now if we integrate the pressure, pw omega square x square by 2, and this will be r1 and this will be r2. Therefore p2 minus p1 is equal to pw omega square r2 square minus r1 square by 2. Therefore omega square is equal to twice p2 minus p1 is rho w r2 square minus r1 square. Therefore just omega की value of omega is under root 2 p2 minus p1 upon rho w r2 square minus r1 का square. So this is the value of angular velocity to which this vessel is rotating around axis of rotation. Thanks a lot.